Warahmatullahi wabarakatuh. My name is Hafiz Furqani, and I will explain about the hybrid system. So, hybrid system. So this is the renewable energy potential in my area, which is this is I got for the solar potential energy. So in my area, as we can see here, it resulting about 4.3 kilowatt hour per meter square per day in direct normal irradiations. By this potential in a day, it resulting in a good solar potential in a year. By this potential, building an independent energy source for residential use will help government target in 2025, which is 20% of the energy source is come from renewable energy. Since the power grid in here is available and reliable enough, so off-grid installation, fully off-grid installation is not preferable since it will cost more in material to support the load for the batteries and for the another generator to support the batteries capacity while the sun is not shine enough. And then while in on-grid installation, we can use it, but we will not get a backup power when the blackout happen in my area. So I prefer to choose installing a hybrid between photovoltaic and also the grid because the grid here is available. It will reduce the cost of me for buying the more batteries since if we use batteries on 24-hour, we should refer to the depth of discharge of the battery itself. We cannot use all of the batteries by just supporting the load. So that's why I choose the hybrid um, with the grid because the grid uh, will support the photovoltaic energy to ensure the load is uh, can be used optimally. So as I said, to overcome this, hybrid system will give more benefits since it has backup power and also able to reduce our electricity bill. So what is hybrid system? Is it a cyberpunk? I think it's not. So hybrid system is a combination between off-grid and on-grid system where it uses more than one power source to supply the load. So in hybrid system, there will be more than one power sources to supply our load. So hybrid system can be differentiated by its power sources and its inverter. The first is hybrid source. We can call this a fully off-grid hybrid. So the source can be from photovoltaic and generator, PV and wind turbine, or all of them combined into one. I think this installation will cost more since we need to put a generator, we need to put a wind turbine, and it will need more maintenance since it has a moving parts rather than if we use just a PV module and connect it to the grid. So for the next is the hybrid inverter. Usually in the market, we can find bi-directional on-grid, which is it can export and import power from the grid and to the grid. And for this one, it is on-grid with limiter. And for the third one is off-grid. Sorry, I did not mention it in here because I don't want to explain about it since the time here is limited. So let's continue to the hybrid on-grid with limiter, what it is. So this is the setup. This is the setup of hybrid on-grid with limiter. As we can see here, this is the inverter and here the sensor for the limiter itself. So the sensor detecting the amount of load in a real time, and then the signal from the sensor will be processed by the limiter, and the limiter will give a signal, another signal uh, to the inverter to compare between the produced power by the PV. Is it enough to support the load alone, or it is need a support from the another source like the grid? So if the produced power is not enough, so it will be supported by the grid. So the grid will be imported by this inverter to support the load. But if we has an excess power from this from photovoltaic installation, it will not be exported back to the grid. So it can import, but it cannot export because it has a limiter there. For the next is hybrid bidirectional. What is hybrid bidirectional? Hybrid bidirectional is a type of hybrid where we combine the more than one power source, and it can export the excess load that we produced back to the grid. As we can see here, the diagram, from here, the PV panel, it goes to the inverter and it will charge the batteries. If the batteries is full, it will the excess power will be exported back to the grid. The main difference between hybrid bidirectional and just on-grid with limiter is this: the energy meter, the smart energy meter, which can measure between export and imported loads. So it will reduce our cost in importing the electricity. Even the regulation right now is not 100%. Our productivity is 100% our used energy. So for the next is the advantage and disadvantage of this hybrid system. And the left one is for the hybrid on-grid, both on-grid with limiter and also on-grid bidirectional. So it has low maintenance since it has no moving parts, just sometimes the batteries we just, and also the photovoltaic, we just need to clean it. And for the batteries, we just need to keep the temperature, but the working temperature is not too high. And then it has lower development costs than fully off-grid. Of course. Why? Because we don't consider to put more batteries, to install more batteries to supply the demand of our load. And it can work in batteryless design. It does not need any battery, but it is only in bidirectional only. And we can become electricity producer in our residential. But yeah, it has a drawbacks also. The first is the regulation and requirements for smart energy meter. It is quite complicated. And then we still pay for the grid. And the next is we need to consider about the battery replacement, but we can bypass this by using the battery just in DOD or in depth of discharge. And although it's still lower cost than fully off-grid, it's still high cost in development. And we goes for the next is hybrid off-grid, which is we combine between off-grid source and off-grid source. So we does not need to pay more to the grid. We don't pay anything to the grid. And this is the true independent energy. Say no more to blackout, but this is also say no more to blackout if we did not use the batteryless design. And then the next, it doesn't concern with regulation, but safety. Remember, safety is the first, but also it has a drawbacks. The first is more maintenance, especially for moving parts, the generator and the turbine and etc. Highest development cost, especially for batteries and also for the generator itself. And it has more battery replacement if we did not consider about the DOD of the battery. And also it has high rupiah per kilowatt hour cost. So I think that's all from me because I have a limited time. Thank you for your attention And wassalamualaikum warahmatullahi wabarakatuh.